Look up at the night sky, and you are seeing the quiet, permanent fixtures of the cosmos. But because light takes time to travel vast distances, many of the stars currently visible have already burned out. We are observing a sky filled with ghosts. The cosmos is an actively evolving structure. Roughly 13.8 billion years ago, it began as a rapid, continuous unfolding of space and time themselves. This initial spark set the entire story of the universe into motion. This is a map showing the cosmic microwave background, the oldest observable light in existence. Captured roughly 380,000 years after the start of the universe, this faint glow remains as a physical memory of the initial unfolding, recorded in minute temperature fluctuations. A system that has a definitive starting point and changes its physical structure every second must eventually reach a conclusion. A living cosmos with a birth faces an inevitable death. The only question left is the method. The mechanics of that death are currently being decided by a tug-of-war playing out across the entire cosmos. Two invisible forces are fighting for control over the fate of everything. Dark matter is the first combatant, making up 27% of the universe. Its gravitational pull acts as a skeleton, holding galaxies in stable, bound structures. But dark energy pushes back. Comprising 68% of the cosmos, this repulsive pressure forcefully stretches the gaps between the threads. Every star, planet, and atom is caught in the crossfire of this interaction. The force that ultimately overpowers the other will dictate the exact manner in which physical reality ends. This is the Andromeda Galaxy, our closest massive neighbor. On this local scale, gravity still holds the upper hand. In about 4 billion years, that pull will cause Andromeda and our Milky Way to merge into a single supergalaxy. Step outside our immediate neighborhood, however, and the physics shift. In the vast gaps between galaxy clusters, dark energy is firmly in control, driving distant galaxies away from us at an accelerating speed. This photograph shows the Hubble Deep Field. Every point of light is an entire galaxy containing billions of stars. We are currently privileged to see this interconnected architecture, but that accelerating expansion is actively pushing these islands of light further into the void. Eventually, the speed of this expansion will exceed the speed of light itself. Distant galaxies will cross a cosmic horizon, meaning their light can never reach Earth again. Future observers will look up at an entirely dark, empty sky. Tracing this trajectory of extreme cosmic isolation forward, physicists have projected 3 absolute scenarios for the end of everything. Fate 1 is the big freeze. If dark energy remains constant, the universe expands infinitely. Galaxies drift too far apart to interact, stars burn out, and the cosmos settles into a state of total, cold silence. Fate 2 is the big rip. If the strength of dark energy grows exponentially, it will overpower the internal gravity of solar systems, tearing apart stars, shredding planets, and finally dismantling atoms themselves. There is also the possibility of the big crunch. In this scenario, the expansion eventually loses momentum, allowing gravity to reclaim dominance. The outward stretch stops and reverses into a violent contraction. Billions of galaxies will crash together as all matter and energy is crushed down into a single, unimaginably hot and dense point, a singularity. While these scenarios represent the destruction of our world, they also mark the exact threshold where our mathematical models and current understanding of physics simply stop functioning. As the universe approaches any of these final endpoints, the current laws of physics begin to break down. The very concepts of space and time, as we define them, lose their structural meaning. Our scientific equations yield impossible answers at the moment of an ultimate rip or a singularity. Matter and energy transition into states that our current physics cannot describe. This breakdown is central to the theory of the cyclic universe. It suggests that a big crunch singularity acts as a seed rather than a grave, providing the exact high-density conditions required to trigger a new Big Bang. Our current dimensional perspective fails to comprehend the mechanics beyond this point. We hit a wall where the math implies a total transformation of the entire system. When water boils, it enters a fundamental phase shift. It becomes steam, a different state with entirely new properties. The end of the cosmos follows a similar logic. entering a new physical reality that our current senses cannot register. Without the familiar physical structures of galaxies to measure it, time might stop flowing linearly. In this extreme state, the past, present, and future could merge into a single continuous reality. Some physicists view the universe as a self-organizing system. If the physical structure of matter dissolves, the underlying information of the cosmos might evolve into a higher state, a unified, multidimensional consciousness that is finally aware of its own existence. The history of the cosmos proves that restructuring is the only constant. Every end we observe in nature serves as the necessary prologue to a new beginning. When the universe finally reaches its limit, it isn't finishing a story, it's starting